Welcome back to The Report. In this segment, we're embarking on an exciting journey into the future of space exploration. As we look to the stars and dream of reaching Mars, scientists are developing innovative technologies to make that dream a reality. Thanks to advancements in nuclear thermal propulsion, scientists are now considering nuclear energy as a potential solution to make the journey to Mars. Could this be the ticket to getting there faster and more efficiently? Well, new research highlights how nuclear thermal propulsion systems could significantly shorten mission times and improve the feasibility of human exploration of the red planet. Here to share his insights on this groundbreaking technology is Dr. Mike Houts, a leading expert in nuclear engineering with a PhD from MIT. Dr. Houts serves as the nuclear research manager at NASA's Marshall Space Flight Center and has over a decade of experience at Los Alamos National Laboratory. With numerous accolades, including NASA's Distinguished Service Medal, Dr. Houts is at the forefront of developing technologies that could transform our understanding of space travel. Mike, it is great to have you back on the program.
No, it's great to be here.
Well, listen, could you begin by explaining how you got involved in the study of space exploration and how long ago and what kind of sparked your interest?
Okay, well, I've always been interested in space exploration. It's, really as long as I can remember. I remember, of course, the Apollo program, the moon landing. I remember Apollo 13. My parents were kind of keeping me a little sheltered there. And all I couldn't figure out is, well, if you're all the way out to the moon anyway, why don't you go ahead and land? And of course, there's many reasons they didn't. But and then, of course, I always liked science fiction shows and shows on TV that dealt with space. And so went to the first 12 space shuttle launches. So I've always been really fascinated by space exploration. But then beyond that, when I got into undergraduate, I had a professor that I talked to down at University of Florida, and he said that the only way we're going to really do something serious in space is with fission energy, with nuclear energy, of course, more advanced nuclear reactions as well. But initially, that we needed nuclear power, we need nuclear propulsion systems if we were really going to do extensive space exploration. And so from there, blessed to be able to go get my PhD up at MIT, and then I was out at Los Alamos National Lab for about 11 years. And then following that, again, blessed to have a really great job at NASA and a really good team that I'm working with now. So it's been, it's been, again, I feel like I've been blessed with a really fun career and a lot of potential as far as contributing to advanced space exploration.
You certainly have. And this new article, this one was published by NBC News, says, can old rocket tech jumpstart a new era of space exploration? NASA thinks that nuclear thermal propulsion might get it to Mars and beyond. So maybe back up for a second and talk about why does it take so long to get to Mars, and what are the primary challenges that astronauts might face that would prolong the journey?
Well, when you go to Mars, Mars itself, it's a long ways away. The closest it ever gets to Earth is about 35 million miles. It can theoretically get a little bit closer. The furthest, it's over 200 million miles away. So long distances to get to Mars. And so it really comes down to not so much the distance, but the orbital mechanics. And so to get there the most efficiently, in other words, to use the least propellant, the least energy possible, people use what's called a Hohmann transfer, but that takes about 8.5 months. And it's just that, any two planets, you can do a Hohmann transfer between them, but it's a pretty long time because you're, again, trying to get there as efficiently as possible. And so one of the ways nuclear propulsion could potentially help is you've removed that energy density constraint, I guess would be one way to phrase it. A nuclear fission reaction liberates millions of times more energy than the best chemical reactions. And so because of that, you eliminate that constraint. Now, there's still a lot of engineering that needs to be done, a lot of ways to try to use that energy, but fundamentally that's the potential you get with a nuclear propulsion system. And then, of course, once we're at Mars, we'll want electricity. Depending on what all we're doing there, might need a lot of electricity. And nuclear reactors also have a lot of potential advantages in places like the surface of Mars.
That's incredible. This is stuff that's in the movies, but you're actually a part of it, and it actually might be possible in the near future, which is an exciting era of space exploration. Now, let's kind of look at Mars itself and say, well, it looks like this very cold, inhospitable planet, but what would it take for us to get to Mars safely? What might we learn when we get there, and what are the possibilities of even colonizing it eventually?
Well, a lot of the elements that we would need for some type of a colony, some type of a large outpost, lots of people, they're already on Mars. You have a carbon and the CO2. You have water, a lot of water trapped in the ice caps elsewhere. We actually think there's water very close to the surface in many regions on Mars. It's about 38% gravity. So you do have gravity, which is important for human health. But also, the good news is, realistically, we'll be having to wear spacesuits and have other things where you wouldn't necessarily want a full Earth gravity while you're on Mars, and so the 38% is good. So it's a long way away, but it's still potentially doable, especially with the advances we're having in technology, things that could help with in situ resource utilization, even the idea of possibly being able to manufacture habitats and other things, at least a lot of the structure once we're there. So, coupled with a lot of power and the ability to get there in a reasonable amount of time, it's not unreasonable. Like you say, it's pushing the, kind of the borders of science fiction. There's still a lot of good science fiction movies come out about Mars, and so, but it seems to be getting more and more doable, pretty much, every day.
And your research, again, is a big part of this. I noticed a quote from you in this most recent article about this technology and about sort of utilizing it for this purpose. Is there a possibility that if this is figured out, we could even go beyond Mars?
Yeah, with kind of the advanced propulsion technologies, when you have things like fission, fusion, maybe antimatter, with all of that, and then coupled with the resources that are available in the solar system, a lot of these systems can use volatiles from anywhere in the solar system for propellant. We should be able to utilize the solar system. And so I guess that the way I'd phrase it, looks like God has designed the solar system so that eventually we'll be able to use it. But to go to the next star with these types of technologies is really hard. I mean, even with the best nuclear propulsion systems, you're still talking thousands of years to get to even the closest star. And even then, you'd have a lot of engineering challenges associated with that. So for that, I think again, if God designed the universe so that we'll eventually be able to travel around the universe, really utilize the universe, then there's some physics that we haven't discovered yet. It's going to take, I'd say, some undiscovered physics. Now, that's also exciting. I know you're very much into astronomy. You may have seen the article. It's just a couple of days ago came out that uses very detailed observations of the Coma cluster of galaxies. I think it's like 320 million light years away. Well, they're figuring out that the way that the header read was that the universe is expanding faster than known physics would allow it to. And so it's kind of it goes through the standard. So maybe there's something we don't understand. And these aren't necessarily Christians doing this research, but everybody's excited about that because they realize we actually really hope there's things that we're misunderstanding. We hope there's physics that we haven't discovered yet, because there's going to need to be if we're really going to be able to travel all over the universe.
Absolutely. Now, you have strong Christian faith. You have a belief system that might vary from some others of your colleagues, but do you think that belief system helps or hurts your research?
I think it helps a lot, because we know, again, God's a very rational, very consistent. We can count on the laws of physics that He's designed, and so if you look at the universe, or you look at everything down to just even the structure of a uranium atom, and you look at that from a standpoint, okay, this was designed this way for a reason. That to me gives you a lot more insight than if we somehow try to pretend that everything just happened randomly. And so most people, I'd say, most scientists and engineers, they actually like very open discussion. They might disagree, like you said, but you usually have very cordial discussions. They're curious about the biblical worldview. They can definitely say some of the key points, things we're finding out now, like just how complicated even the so-called simple life is. And so now when you say, hey, is it about time to give up on this idea that maybe life's evolving places? A lot of them will agree. I mean, they won't necessarily affect their day-to-day research. You hope that eventually they become at least seriously consider the Bible, seriously consider becoming a Christian. But it's to me, it helps personally, and it's also, there's not really a lot of antagonism. You get again, a truly objective, open-minded scientist and engineer, and by definition, those are the best ones. They love to talk about just about anything, especially if you get pizza or something involved. So it's it's really it's great for the career.
Absolutely. And again, that good science should be open to understanding, to trying to explore different possibilities. And honestly, everything that we're finding within the scientific community, breaking cutting edge research, is pointing us right back to our Christian faith. Again, this show is a predominantly Christian show. We're talking about biblical worldviews. So maybe in the final moment, what advice would you give to young viewers who might be considering a career in science or engineering? Maybe they want to become the next you and work with NASA to develop these things and to really make a difference for science. How can they navigate their faith alongside of their professional ambitions?
Well, I think it's a great science and engineering. It's a great field if you're interested in it. It's really fun. I mean, it's a very fulfilling career, but it's also a great mission field because a lot of people you run into, again, I'll just say the best scientists and engineers, they keep an open mind. They look at all the possibilities, and so they're very easy to talk to, very open to talk to. I know some people have bad experiences. Some of it's just not even willing to discuss or entertain an idea, but in general, it's both a very fulfilling career, but also it is a great mission field. The reason I say that is a lot of times people, they grow up outside the church, they just they've never heard any of the alternatives, they don't think as much about stuff, and boy, if you get them into a 30-second conversation and they start thinking, they start they get curious. I mean, they start saying, hey, this actually makes a lot more sense. And like you say, I mean, true science is catching up with the Bible. And so
absolutely.
So that's fun also. I mean, the more we learn about science, the more it's I'll just say it's catching up with the Bible. The Bible's not changing, but the science is catching up. And so again, it's really exciting. Don't be again, just view it as a mission field, because like any other mission field, you'll have your good days and your bad days, but view it as a mission field, but also a really, really fun career if you're interested in it.
The Bible has stood the test of time. Thank you so much, Dr. Houts, for sharing with us.
Oh, my pleasure. Thanks for having me on the show.
Absolutely. And that is it for today. I want to thank you for joining us on the Genesis Science Report. Until next week, keep looking up. I'm David Rives. Truly, the heavens declare the glory of God.